This approach also let researchers sidestep the biggest obstacle blocking earlier historians from making any quantifiable claims about Habsburg inbreeding at all. Simply counting first cousin or uncle-niece marriages told you something, but it understated the real picture, because it ignored how earlier close marriages kept compounding through later generations. Only a full pedigree simulation, tracking every ancestral connection simultaneously rather than one marriage at a time, could capture that compounding effect accurately. That percentage has a name in genetics. It's called the inbreeding coefficient, and it functions almost like a genetic credit score for how concentrated and repetitive a person's ancestry actually is. A child of two completely unrelated parents typically has an inbreeding coefficient close to 0. A child of first cousins typically lands somewhere around 6%. A child of a parent and their own offspring, or a child of full siblings, the two most extreme forms of close relation biology recognizes, lands at a theoretical 25%, meaning a full quarter of that child's genome is expected to be doubled up from shared ancestry. When the simulation reached Charles II, the final Spanish Habsburg king, the number it produced was not just high. It was almost unbelievable given his actual documented parentage. His inbreeding coefficient came out to roughly 25%, statistically indistinguishable from what you would expect from a child born of a parent and child, or of two full siblings. And yet Charles was neither. His parents were, on paper, uncle and niece, a close relationship, certainly, but not one that should mathematically produce a number that extreme. The explanation turned out to be even more unsettling than a simple uncle-niece pairing. Charles's ancestors were not related through just one line. They were related through dozens of overlapping lines simultaneously. Uncles marrying nieces who were themselves descended from earlier uncle-niece marriages, cousins marrying cousins whose own parents had already shared multiple sets of grandparents. Each individual marriage looked, on its own official record, like a single close relationship, but stacked across 5 or 6 generations of the family, repeatedly intermarrying with itself, those individual relationships compounded on top of each other, mathematically multiplying the concentration of shared ancestry far beyond what any single generation's marriage certificate would suggest. Charles's uncle-niece parentage was, in effect, the tip of an iceberg built from more than a century of the same handful of family lines folding back into themselves again and again. If a story like this, where centuries-old paperwork gets reverse-engineered into genuine biological proof, is the kind of deep dive that keeps you coming back, go ahead and hit that subscribe button, because untangling exactly how history quietly rewrote itself through decisions nobody fully understood at the time is precisely the kind of story this channel exists to tell. This genetic reconstruction did not exist in isolation either. A separate team of researchers approached the same royal family, from a completely different angle entirely, this time using something you can still see hanging in museums across Europe today, official court portraiture. Spanish Habsburg rulers were painted obsessively by masters like Diego Velázquez and Juan Carreño de Miranda, and those portraits preserved something researchers realized they could actually analyze scientifically, a distinctive, recurring facial deformity that art historians had noticed for centuries but never rigorously measured, a pronounced lower jaw combined with an underdeveloped upper jaw, a combination now widely known as the Habsburg jaw. A team of maxillofacial surgeons was brought in to examine these portraits with clinical precision rather than art historical appreciation, measuring the degree of mandibular prognathism and midface deficiency visible in each painted royal face, then cross-referencing those measurements against each individual's independently calculated inbreeding coefficient from the genealogical reconstruction. The correlation the researchers found was strong and statistically significant. The more inbred a given Habsburg ruler was, according to the paper genome built from marriage records, the more pronounced their jaw deformity tended to be in painted portraits completed decades or centuries before anyone involved understood genetics at all. 2 entirely separate lines of evidence, one built from court paperwork and computer simulation, the other built from careful analysis of oil paintings, were independently converging on the exact same conclusion. What made this cross-validation so persuasive is that portraiture and pedigree data have nothing to do with each other on the surface. A royal court painter had no concept of inbreeding coefficients and every incentive to flatter a royal subject rather than document their imperfections honestly. The fact that a physical trait preserved in paint for centuries lined up so closely with an entirely independent mathematical reconstruction is exactly the kind of convergence scientists look for when confirming a pattern is real rather than coincidence. None of this happened in a vacuum either. Charles II's medical history reads like a case study in exactly what extreme inbreeding can do to a human body. He reportedly could not walk properly until around the age of 8, struggled his entire life with chewing and swallowing because of his jaw deformity, suffered chronic digestive problems, and experienced significant intellectual disability. Contemporaries nicknamed him El Hechizado, the Bewitched, or the Hexed, because his condition seemed so severe and so mysterious to observers who had no framework for understanding genetics whatsoever. Married twice, he produced no children, and when he finally died in 1700 at just 38 years old, the male Habsburg line in Spain died with him, triggering a 13-year war fought across Europe simply to determine who would inherit a throne the family's own marriage strategy had rendered impossible to responsibly pass on. Of course, no reconstruction built entirely from documents, rather than physical remains, can claim absolute, unquestionable certainty, and responsible researchers involved in this work have been careful to acknowledge exactly where the limits of this method sit. Genealogical reconstruction is only as accurate as the historical records feeding into it, and while European royal marriages were documented with unusual thoroughness compared to almost any other population in history, gaps, errors, and occasional ambiguities in centuries-old church and court records remain an unavoidable source of uncertainty. Some historians have also pushed back against attributing every one of Charles's ailments purely to inbreeding, noting that other explanations, including hormonal disorders, contemporary medical treatments involving mercury, and simply the poor state of 17th century medicine in general, likely compounded whatever genetic burden he was already carrying. The consensus among most researchers is not that inbreeding alone explains everything about Charles' condition, but that it explains an unusually large share of it, more than any single alternative explanation on its own. There's also a broader scientific debate worth acknowledging about how far conclusions drawn from a single family, however well documented, can really extend. Some geneticists outside the original research team have pointed out that the Habsburgs, despite their unusually thorough paper trail, remain a single case study, and that drawing sweeping conclusions about inbreeding depression in humans generally from one royal family's fate risks overstating what the data can actually support. Other researchers examining the same reconstructed pedigree have noted that infant and child mortality rates across the dynasty did not rise in a perfectly smooth line alongside inbreeding coefficients, but instead showed uneven jumps between different generations, suggesting that other factors, from changing medical practices to shifting disease exposure across the centuries, were also shaping outcomes alongside genetics, rather than genetics acting entirely alone. It's also worth being precise about what this research does and does not claim, because the headline version of this story tends to flatten some important nuance. This was never a case of scientists discovering a secretly illegitimate child slipped into the royal bloodline, no hidden affair, no falsified birth record, no imposter wearing a crown that belonged to someone else. Every official marriage and birth in this reconstruction checks out exactly as history recorded it. What the mathematics revealed instead was something arguably more disturbing precisely because it was entirely legal, entirely sanctioned, and entirely intentional. A bloodline that was completely legitimate on paper and yet had become, through generations of deliberate consolidation, genetically almost indistinguishable from outright incest. In a laboratory in northern Spain, a team of scientists rebuilt the genetic code of an entire royal dynasty without ever opening a single tomb. No bones, no blood samples, no exhumations. Just centuries of marriage records, baptismal certificates, and court documents fed into a computer model powerful enough to simulate exactly which genes passed from parent to child, generation after generation, for nearly 300 years. What that reconstruction revealed was not a forged bloodline or a secret affair hidden in the palace shadows. It was something almost stranger, a king whose genetic profile was so extreme that, mathematically speaking, he should not have been the son of an uncle and a niece at all. He should have been the son of siblings. To understand why that finding stopped geneticists in their tracks, you have to understand exactly what the House of Habsburg was trying to protect, and exactly how far they were willing to go to protect it. For nearly 2 centuries, the Spanish branch of the Habsburg dynasty ruled one of the largest empires the world had ever seen, stretching from Madrid to Mexico City to Manila. And for nearly that entire span, the family followed one unbreakable rule: keep the bloodline pure by keeping it inside the family. Uncles married nieces. First cousins married first cousins. In one case, double first cousins married each other, sharing not one, but 2 sets of grandparents. This was not scandal. This was strategy, a deliberate, calculated policy designed to keep the crown, the territory, and the wealth from ever slipping into a rival royal house. For a long time, historians could only guess at the true cost of that strategy using portraits, letters, and second-hand accounts of illness and disability within the family. What they lacked was hard, quantifiable proof of exactly how inbred these rulers actually were, and exactly how much that inbreeding shaped the disasters that eventually toppled the dynasty. That gap is precisely what a team of researchers at the University of Santiago de Compostela set out to close, and the tool they built to close it turned 4 centuries of scattered genealogical paperwork into something close to a genetic fingerprint. What makes this story different from a typical royal scandal is that nobody involved was hiding anything. Every marriage the Habsburgs arranged was public, celebrated, recorded in exhaustive detail by court clerks who understood exactly how closely related the bride and groom were, and considered that closeness a feature rather than a problem. This was not a family stumbling accidentally into consanguinity through ignorance. It was a family with access to some of the best theological and legal advice in Europe, repeatedly seeking special dispensation from the Catholic Church to marry uncles, to nieces, and cousins to cousins, because keeping the throne inside the bloodline mattered more to them than any risk they may have vaguely suspected, but had no scientific way to quantify. Let's rewind to where this dynasty actually began, because the roots of the story matter enormously. The Habsburgs rose to prominence in the 13th century as a minor noble family from what is now Switzerland, and through a combination of military conquest, political maneuvering, and above all, strategic marriage, they gradually assembled one of the largest personal empires in European history. Their unofficial family motto, often quoted by historians, roughly translates to, "Let others wage war, you, happy Austria, marry." It was a policy that worked spectacularly well for generations, absorbing entire kingdoms into the family portfolio through wedding contracts rather than bloodshed. The Spanish branch of the family was born from exactly this kind of marriage, when Philip, a Habsburg archduke, wed Joanna, heir to the combined thrones of Castile and Aragon, the very kingdoms that had recently funded Columbus and driven the Reconquista to its conclusion. But the same marital strategy that built the empire eventually turned inward and began quietly destroying it. Once the family had already absorbed most of the territory available through marriage to outsiders, Spanish Habsburg rulers increasingly turned to marrying each other instead, reasoning that keeping the crown entirely within the family eliminated the risk of foreign claims or divided inheritance. Over 11 major dynastic marriages spanning roughly 200 years, 9 involved close biological relatives, including 2 separate uncle-niece unions, and at least 1 marriage between double first cousins, a relationship so close it produced offspring with roughly the same genetic overlap as children of siblings. This pattern intensified as the decades passed, rather than easing off. Early Spanish Habsburg rulers like Charles I still occasionally married outward, bringing in fresh genetic material from other European royal houses. But by the time the throne reached Philip III and then Philip IV, the pool of politically acceptable marriage partners outside the family had narrowed considerably, and the pull toward keeping the succession locked entirely within trusted Habsburg hands grew stronger with every generation. Each ruler who married a close relative was, in isolation, making what looked like the safest possible political decision. It was only when you stacked 5 or 6 of those decisions on top of each other across a century and a half that the biological consequences began compounding in ways nobody at the time had any tool to detect. If you've ever wondered how a royal family could accidentally engineer its own extinction through paperwork and wedding vows rather than war or plague, this is exactly that story, and it only gets stranger from here. Here is where the actual science gets genuinely clever. Since no living Habsburg descendant was going to volunteer a cheek swab for a 400-year-old mystery, and exhuming royal remains across multiple countries was neither practical nor appropriate, the research team took a different approach entirely. They built what is essentially a paper genome, reconstructing a family tree containing more than 3,000 individuals across 16 generations, cross-referencing baptismal records, marriage contracts, and court genealogies held in Spanish and Austrian archives. Every documented birth, marriage, and death became a data point. Every known family relationship became a mathematical link in an enormous chain. Once that skeletal family tree existed, the team turned to a computational technique that simulates inheritance itself. Using a method that models how genetic material statistically passes from parent to child across generations, researchers ran the reconstructed pedigree through repeated simulations, essentially asking the same question for each individual over and over across thousands of trial runs, given exactly who this person's parents, grandparents, and great-grandparents were, and exactly how many times those ancestral lines doubled back and intersected with each other. What percentage of this person's genome would statistically be expected to be identical by descent, meaning inherited from the same shared ancestor through both the mothers? Think of it less like reading a single document and more like running a weather forecast. But instead of predicting rainfall, the model predicts genetic overlap. Run that simulation once and you get a rough estimate. Run it thousands of times across a pedigree of more than 3,000 people, and the estimate sharpens into something close to statistical certainty, precise enough to compare directly against known genetic thresholds for parent-child, sibling, and cousin relationships. Step back far enough, and this becomes a story about something much larger than one unfortunate king. It's a story about how a strategy explicitly designed to concentrate and protect power can, given enough time and enough repetition, mathematically collapse in on itself in ways nobody at the time could have predicted or measured. The same marriages that Habsburg rulers celebrated as triumphs of dynastic security, each one carefully negotiated to keep territory and titles safely inside the family, were simultaneously and invisibly stacking a genetic debt that would eventually come due in the body of a single sickly king born at the tail end of it all. Nobody in the 16th or 17th century had any way of seeing that consequence coming. It took 21st century computational genetics, applied not to bone or blood, but to baptismal registries and court paperwork, to finally make that invisible cost visible, calculable, and undeniable. There's something quietly haunting about the fact that Charles II spent his entire short life being called bewitched, cursed by forces nobody around him could name or explain, when the true explanation had been sitting in plain sight the entire time, recorded neatly in marriage contracts his own. Ancestors signed with pride. The empire that once stretched across 4 continents did not fall to a rival army or a foreign conspiracy. It fell, in the most literal genetic sense possible, to its own family tree, a slow-motion collapse written into the paperwork centuries before anyone possessed the tools to read what it actually said. And perhaps the strangest part of this entire story is how ordinary each individual decision looked at the time it was made. No single Habsburg ruler ever sat down and decided to gamble the future of their empire on a roll of genetic dice. Each marriage was negotiated, carefully, blessed by the church, celebrated across the court, and justified by the same logic that had protected the family's power for generations before. It was only when researchers, centuries later, ran every one of those individually reasonable decisions through a single unified simulation that the cumulative cost became visible all at once, a debt that had been quietly accruing interest for 150 years before it finally came due in the body of one sickly king. This is also, in its own way, a story about the limits of hindsight and the strange power of modern tools to finally answer questions people could only wonder about for centuries. Court physicians in the 1600s examined Charles II constantly, documented his ailments in exhaustive detail, and never once landed on an explanation that came anywhere close to the truth, because the truth required a mathematical framework that would not exist for another 250 years. It took 21st century computing power, applied patiently to paperwork nobody had thought to analyze this way before, to finally close the loop between a family's proudest political strategy and its most devastating unintended consequence. If you found this story as unsettling as the researchers clearly did, let me know in the comments whether you think any modern institution, corporate, political, or otherwise, is quietly repeating the same mistake today, consolidating power so completely and so carefully that it never notices the slow cost accumulating underneath its own success until it's far too late to reverse course. And if stories like this, where centuries-old paperwork gets reverse-engineered into hard, undeniable scientific proof, are exactly the kind of history you want more of, make sure you're subscribed, because this is exactly the kind of mystery this channel was built to untangle. I'll see you in the next one.